All right, everybody. I want to put together a couple of final screencast videos to help out with screening and running through some of these ANOVA designs. The handout and the data set I'm going to be working with in these next couple of videos is going to be the conservatism handout that we passed out but didn't work on, and the 2x4 ANOVA conservatism data that we hand out. So these are some fabricated data, basically wanting to look at the unique and combined impact of respondent sex and religious affiliation on a hypothetical measure of conservatism. So if you pull up our conservatism data set here, we've got just variables that we need for this analysis: participant number, our conservatism rating, gender, and religious affiliation right here. So first thing we want to do in our screening, I wanted to go through and check to see if we've have any missing values. So I'm just sorting these. Okay, so it looks like we've got 3 cases where we are missing religious affiliation. Since we can't use those because religious affiliation is a variable in our set, I'm going to go through and delete those cases, and then I'm going to resave this file as conservatism. We'll call it screening. Okay, so would want to mark down the cases that I deleted there. In this case, there were cases 99, 103, and 586 missing because we didn't have religious affiliation there. Now what we want to do, go through and do a quick check on our categorical variables, make sure that those are all within range, that we don't have anything that's hanging out that's odd. So we're going to go gender, religious affiliation in frequencies, and hit OK. So it looks like 462 people total left in the set. Relatively equal balance between men and women, and then we have people identifying as religiously unaffiliated, people who are identifying with Catholicism, people identifying as Protestant, people identifying with Judaism. If we go through and pull up our handout here, we see male, female, we've got that marked down, and then religious affiliation here. So looks like we're doing well. At least our categorical values, variables are in range. So, but because we have a 2x4 ANOVA, we're going to have 8 different individual groups that we're going to be looking at. We need to screen all of these individually. So what I'm going to do is I'm going to go through and I'm going to sort first by gender, and then I'm going to sort by religion. I'm going to go down through and check. So I should have all of these ordered up. It looks like I do. And so what I'm going to do is I'm going to create a new variable here just to help me with the screening. So my first group will be all our unaffiliated men. Second group, unaffiliated women. And so on and so forth. And what this is going to do is it's going to allow me to go through and split my file by condition, which will then help me evaluate individual distributions and things along those lines. Tedious. You can fast forward this if you like. 7. All right. So there we go. We'll go through, name this condition, and then just to make our lives easier, label this male, there we go, none, male, none, female, what are we, Catholic, male, Catholic, female, 5, seven, 8. Okay. Kind of tedious, but that will help in terms of keeping all of our stuff straight once we're going through and running our screener. So we've got everybody set up here. Sort these up, save our set. So what we'll do now is go through and start taking a look at our distributions, but remembering that we want to look at these individually for each individual subgroup that we have for this 2x4 ANOVA. We're going to organize our output by groups. We're going to go to condition, put our condition variable in there, and then hit OK. So now whatever we do, unless we sort, is going to be set up and split by each one of our 2x4 cells here. So what we'll do is we'll go, and actually I'm going to paste that to a document there. Okay. So what we want to do now is take a look at individual distributions. So we'll go descriptives, look at conservatism, options. We'll ask for skew, kurtosis. I'm going to ask for variance just so I can kind of eyeball, see if we can anticipate any difficulties there. But that should get us that. Save standardized values as variables. Remember that this is going to save z-scores for each one of our cases, but it's going to use the mean of our individual cells as the mean value with the split on here. So just make sure that that's doing that appropriately. I'll go ahead and hit paste. And if we run this, all right, we can start looking at our individual groups here. Okay, so looking first, 46, 30, 63. So it looks like all of our cell sizes are fairly large, but different, right? It looks like our smallest are our unaffiliated women. Largest cell is our Protestant men. So we've got differences in our cell sizes that we'll want to keep in mind in the back of our head. Other thing we want to do is make sure to take a look at our conservatism values, make sure that they're within bounds. Now this conservatism, hypothetical conservative measure ranges from 1 to 10, but so we've got everything that's in bounds. But if you're noticing, it looks like what we've got is at least something we might want to take note of. We don't have the full range. It looks like our lowest value here is 5, jumping up to 10, and so that's something that'll be worth noting in your screening, that it looks like we have some truncation of our outcome variable working with values just on the sort of top half of the distribution. But if we look at our skew and kurtosis values, these are all looking good. We've got some negative skew, negative kurtosis, but I think that kurtosis value of negative 1.29 is the highest. So at least from our indices here, it's not looking like there's anything going too terribly awry in terms of overall distribution. We've got relatively large sample sizes, so it looks like we're not concerned with the distribution of sample means, or we shouldn't be concerned with the distribution of sample means as we're moving forward with stuff. Last thing I might want to take a look at is variances. We're going to run a Levene's test, but Levene's test is going to be pretty sensitive in a sample of this size. So you just want to see absolute magnitude of differences and variances. But again, these are all looking reasonably similar. So we've got a low value that's less than 1.98, but everything else is really close. We could run and take a look at the ratio of the largest to smallest, but we're well within the bounds of what we would consider reasonable to move forward with our ultimate factorial ANOVA. So we've taken note of sample sizes or cell sizes. All of our values are within range. Our skew and kurtosis indices seem reasonable based on this initial run, and fast forward preview on variances. Those are all looking okay. So we're looking in pretty good shape up to this point. So, but want to go through, take a look graphically at our variables. So what I'm going to do is I'm going to go through and I'm going to sort this. That's going to take that split file off. So then if I go to Analyze, Descriptive Statistics, and Explore, conservative is our dependent variable, condition as our factor variable, and then participant number, we're going to label cases there. For plots, I'm going to turn off stem leaf, turn on histogram, hit OK there. Then we should be good to go. And hit paste, and then run this. All right. Here's our summary, all our good statistics that you could go through and take a look at if there's something in there that's worth or that's of specific interest for individual screenings. But what we're really doing this is recall to take a look at our histograms. So that's looking pretty good. That's not too bad. That's looking all right. So our histograms are looking pretty good. So we don't have any scores that are detached from anything else. This one is looking maybe a little bit skewed left, but not bad at all. That's not got kind of a bimodal thing going on right there. But again, nothing too bad. So our histograms aren't indicating any severe violations of normality, at least in our observed distributions here. So again, this is nice, suggesting that we don't have any, shouldn't have concerns about distribution of sample means, which is going to be our normality assumption under ANOVA. Finally, going to take a look at our box and whisker plot, and you can see that this starts to get pretty, as our factorial designs start to get increasingly large, then our number of groups jump up really fast. And so again, when you're thinking about putting designs together, wanting to think about, as you start adding in factors, being cognizant that that's going to increase the size of your design a great deal, which makes screening and interpretation and things like that increasingly complicated. But if we go through, take a look at these box and whisker plots, one thing I might notice first, looks like our median values are the same for all of our groups with the exception of unaffiliated women. So our median score across each one of our cells is identical at 8, with median value for our unaffiliated women a little bit lower at 7. Looks like we have maybe the most variability in our unaffiliated men and our Protestant women, but we've got some values falling beyond 1.5 times the interquartile range for unaffiliated women, have ones above and below, Catholic men, a couple scores up here, Protestant men, one high score, a couple low scores, and Jewish men, a couple of low scores here. So we'll want to go through, take note of that, and highlight features to document down in the screening, keeping track of your individual case numbers there that are registering as potentially problematic. So, but to this point, things are looking okay. Last thing we want to do then is take a look at these z-scores. So what I'm going to do is I'm just going to resplit my file by condition, and then we'll go through, we'll analyze, descriptives, take a look at our z-scores. We don't know z-scores. I'll turn off all of these, continue, and then paste that in. Run both of those. Okay, and so then what we've got is looking at our min and a max for our z-scores here. So looks as though for our unaffiliated men, everything's below 2, which isn't 2, which is pretty good. Unaffiliated women, it looks like we have at least some cases falling above 2 standard deviations above the mean for unaffiliated women. Same thing for Catholic men. Our Catholic women are all below 2. For Protestant men, we have some low values, some high values here. Protestant women, some low values. Jewish men, low values, and our Jewish women all falling within scores falling within 2 standard deviations there. So doesn't look like we have any real strong concerns with extreme values, which makes some sense given our scale only runs from 5 to 10. But for the purposes of writing up my screening summary, what I'd probably do, sort these and then start to take a look and document where I've got low values here. So it looks like condition 6, this is going to be my Protestant women. We've got a couple of scores of 5 on my conservatism scale that are registering more than 2 standard deviations below the mean for what do we got? 6 Protestant women, and then we've got for Jewish men a couple scores that are falling, scores of 5 falling again below 2 standard deviations below the mean, and then the same thing for our Protestant men, score of 5 corresponding to z-score of negative 2.31. So I wanted to document those just to take note. If we go all the way down, same thing here. We have a group of values falling above 2 for, what do we got? Protestant men, Catholic men, and then 2 is our unaffiliated women here. Okay, so again, these aren't huge values, and probably not anything that we're going to be concerned about in terms of our overall screening, but relatively high for this set, and so something we might want to document. Okay, last thing we would want to take note of in terms of our screening is once we run our ANOVA, want to report our Levene's test to take into consideration homogeneity of variance. Again, if we go up through and take a look at our variances for each one of our cells, they're all pretty similar. Our Levene's test is going to be pretty sensitive with, how many people do we have in this? 462 people total, right? But when we run the ANOVA, Levene's test is not statistically significant at a p-value of, what is it, 0.017, I think, or excuse me, 0.107, something along those lines, 0.103, and so we end up being okay there. So overall, if we were to go through and write this up in our standard screening, we would want to say missing data, document our missing cases there, accuracy and plausibility, all of our values falling in range, distributions. Here we've got 8 different cells to work through, so we can start to summarize this a little bit. Would identify or talk about this as relatively unremarkable in terms of distribution. So saying all of our skew and kurtosis values for all groups falling less than 2. No clear violations of normality in our histograms. Box plots, you have equal medians across all groups with the exception of non-affiliated women, have a lower median there. Some evidence maybe of increased variability, non-affiliated men and Protestant women relative to other groups, and then documenting cases in which we found scores falling beyond 1.5 times the interquartile range, specifically for unaffiliated women, Catholic men, Protestant men, and Jewish women. In terms of outlying values, What I've done here is just documented all of our individual cells, as well as the size of the cells. Unaffiliated men, nothing much going on there. Had an elevated score with unaffiliated women, and then going through and documenting the same for Catholic men, Catholic women, so on. Or well, Catholic women were fine; they didn't have anything exceeding our values, but everything there. Levine's test, I want to document that. Failing to provide evidence for violation of homogeneity variance, and then our summary. Okay, just want to do just a quick recap. Looks like we don't have much evidence for underlying violations of underlying assumptions. Noting we do have an unbalanced design, though, but skew and kurtosis look within reasonable bounds. Histograms look all right. Some values that are starting to get large, but nothing that's going to be problematic in this test. Not a problem with Levine's. Noting that we do have some restriction of range within the set, assuming that people can and do score on the low end of 1 all the way up higher to 10. All of our values were between 5 and 10, so something to take note of. But aside from a relatively unbalanced design, everything looks to be pretty good to go here in terms of our screening. So we'll leave this at that, and then pick up with the next video working through our actual analyses of these data in the 2x4 ANOVA.